How's it going, everybody? It's your bro here, hope you're doing well, and in this video we're going to be discussing multi-threading in Java. We're going to be counting up and counting down at the same time. How about that? Let's get into it. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright everybody, let's discuss the definition of multi-threading real quick. So this is the process of executing multiple threads simultaneously, and it helps maximize the utilization of your CPU. And with threads, they are independent, so they do not affect the execution of other threads, and an exception in one thread will not interrupt other threads since they run independently. And this is useful for serving multiple clients, multiplayer games, or other mutually independent tasks. So let's do some multi-threading right now. So what we're going to be doing for this example is that we're going to create two separate threads, and each of these is going to have basically a sub-program. In the first thread, we'll create a simple counter that will start at 10 and count down to 0, and in the other thread, we'll do the same thing. We'll have a counter, but let's start at 0 and then count up to 10, and both of these threads are going to run at the same time and display the results as they continue. So there's two different ways of creating a thread. The first is that we can create a subclass of the thread class. So let's try that. So within your project folder, go to File, New, Class, and let's call this maybe my thread. It doesn't really matter, just make sure that this subclass extends the thread class. And then we're going to need to override the run method of the thread class. So we're going to type in public void run, parentheses, curly braces. And since we're overriding a method, it's good practice to add at override, although it's not necessary. So when we start the instance of this thread class, it's going to execute this run method. So let's create an instance of my thread within our main class. So we're going to type in my thread or whatever else you named this. And let's call this first thread thread1 equals new my thread. Alright, so when we eventually start this thread, it's going to execute this run function. So what do we want this to do? Well, this is a great time for us to place our counter program within here. So we can do this with a simple for loop. So we'll start at 10 and then count down to 0. So we'll put for int I, set this equal to 10. We'll continue I as long as I is greater than 0. And then we'll decrement I by 1 after each iteration of this for loop. So within this for loop, let's just system.out.println, maybe thread number 1, and then we'll display whatever the current value of I is. So we don't want this to run like instantaneously. Maybe we would like some sort of like pause for like 1000 milliseconds between each of these iterations to simulate like a countdown. So what we can do is just type in thread.sleep. Then within here, we want this to sleep for 1000 milliseconds after each iteration. And then since we're using this method, we have to surround this with a try and catch block. So make sure you put that in as well. All right, so then once we exit this for loop, let's just display a message such as thread number 1 is finished. Alright, and that's all there is to it. So there's another way that we can create a thread. So the other way is that we can create an instance of a class that's implementing the runnable interface, and then we can pass this instance within the constructor of a thread object. But I'll show you how to do this. So within your project folder, go to File, New, Class, and we're going to be implementing the runnable interface. So let's call this class maybe my runnable, and click Finish. So we're going to have my runnable implements runnable, and then we need to add unimplemented methods. So since we're using an interface, we need to use all methods that runnable have within its interface, and that is the run method within here. So going back to our main class, what we're going to do is create an instance of my runnable. So my runnable, and let's call this runnable 1 equals new my runnable. Now the second step is that we're going to take runnable and send this within the constructor as an argument within the thread class when we create an object. So we'll type in thread not my thread, and let's call this thread2 equals new thread. And then within the parentheses of thread, just place your runnable instance within here. So this is the other way of creating a thread. Use a subclass or a class that's implementing the runnable interface, create an instance of it, and then pass it as an argument to the thread class. So there's two ways in which you can create a thread. The first way is that you can create a subclass of the thread class. So you just create a class name and make sure it extends the thread class, and then you have access to a run method. And the other way is that you create a class that implements the runnable interface, and then you take this instance and pass it as an argument to the constructor of the thread class, and then that's how you get your other thread. So you can do it either way. It depends on how you want to write your program. Like for this example, we could have done like thread1 and thread2 by using the myThread class. Otherwise, we could have done like myrunnable2 and, thread2 the other way. But for this example, I wanted to show you guys both ways. But yeah, you basically have two different ways of creating threads. Personally, I tend to prefer to use the runnable class or the runnable interface and then pass this instance as a constructor to the thread class. Because with this class, you can still use inheritance, like we can extend another class. But if you use this class as a subclass of the thread class, well, in Java, you can only have one parent, so we can't have another class as a parent. We're limited to just one, the thread class. However, we can implement another interface. So just from my own experience, people tend to use the runnable interface more compared to extending the thread class. But do what works for you, though. But I'm getting off track again, so we should probably finish this program. So we need to fill in the run method of the myRunnable class. So what we can do actually is go to the myThread class and copy everything here and make a few changes. So I'm going to copy this and then paste it within the run method of the myRunnable class. So instead of counting down from 10, let's count to 10 starting from 0. So we'll set I equal to 0. We'll continue this as long as I is less than 10. And then we're going to increment I by 1 each time. And then let's change system.out.println thread number 1 to thread number 2. And then down here, after we exit this for loop, we'll display thread number 2 is finished. Alright, so that should be everything. So let's go to our main class. We're going to start thread 1 and thread 2. So we'll type in thread1.start as well as thread2.start. And that's it. Let's run this. So thread 1 starts at 10, thread 2 starts at 0, and you can see that they're both either counting up or counting down, depending on, which one is running. But you can see that they're both running at the same time, and they finished at the same time. So that's one of the great benefits of multithreading, because it's kind of like you can make your own subprogram that runs independently. So, ladies and gentlemen, we have successfully multithreaded. And one of the great things about multithreading is that if one of these threads encounters an exception and gets interrupted, the other threads will still continue. So let's actually intentionally cause an exception. So within the run method of the myThread class, let's divide a number by 0, which we can't mathematically do. So I'm actually going to fit this maybe within the for loop. So what I'm going to do is just within a println statement, I'm going to divide number 1 by 0. So this will throw an arithmetic exception. And let's see what happens now. So you can see right off the bat, thread 1 encountered an exception. The technical name of the first thread is thread-0, but that is thread 1 for all intents and purposes. But you can see that even if our thread 1 stopped, thread 2 still continued along with our main thread. So let's actually take this and then move it within our main class. So how about after these thread start, thread 1 and thread 2, we'll divide by 0 right after these threads start. So it says exception in thread main, but these threads are still continuing. So that's proof that threads can run independently, and if one thread encounters an exception, the other threads will continue still. Now, there's one method I want to talk to you guys about, and that is the join method. So the calling thread that calls this join method will actually wait for a specified thread to die until it resumes. So let's say that we want thread 2 to start right after thread 1. So what we'll do is type in the thread that we're waiting to die, or finish, basically. Let's say thread 1. So what ends up happening is that if we type in thread1.join, we're going to pause our main thread until thread 1 is completely done. And then we'll need to either surround this with a try and catch block or add throws declaration, which I did at the top. So if we type in thread1.join, the main thread is going to wait until thread 1 is finished, and then it's going to continue on with the rest of the program. So let's try it. So thread 1 is running right now, but thread 2 doesn't appear to start. And then once thread 1 is done, thread 2 will start because our main thread resumes with the rest of the program. So it says thread 1 is finished, and then thread 2 started right after that. So you can also put an amount of milliseconds in here, and that allows for like a delay. So for example, if we put 3000 milliseconds in here, the main thread is going to be paused for 3000 milliseconds before the main thread will continue. So let's try it again, but place 3000 within here. So it's going to wait 3 seconds before thread 2 begins, and that seems about right. So then thread 1 is about to finish, and then thread 2 is going to finish a little bit later, right about now. With the join method, the calling thread, and for this example, it's the main thread, will wait until the specified thread dies or for X amount of milliseconds. Hey, you know what? I forgot to talk about daemon threads in this video, so I should probably do so before we wrap things up. So a daemon thread is a background thread. It is a non-user thread. So user threads and daemon threads are kind of like opposites. So the Java virtual machine will not wait for any daemon threads before exiting, but as long as there's one user thread, the Java virtual machine is going to wait to exit until all user threads are finished. So let's take our previous example where we divided a number by 0 within our main class. So what we did for this example is that the main thread encountered an exception, but these other two user threads are still running. So since there's at least one user thread that is still running, the Java virtual machine will not exit until all user threads are complete. But if we were to set these as daemon threads, well, the Java virtual machine is going to exit then as soon as all user threads are finished. So let's change these to daemon threads. So we'll take thread1.set daemon and set this to true. And we'll do the same thing for thread 2. So thread 1 and thread 2 will no longer be user threads. They are the opposite, basically. They are daemon threads. And when we run this program, well, we don't get that countdown anymore. We have an exception in thread main, and the Java virtual machine actually terminated because there were no more user threads. We had some daemon threads running in the background, but they terminated because the Java virtual machine doesn't care if they're running. It'll exit regardless. So that's the basics of multithreading, and just as a reminder before you go, there are two different ways of creating threads. I just so happen to use both of these ways for this example. You can either create a subclass of the thread parent class, or you can implement the runnable interface and pass that instance as an argument to the thread constructor. So you can do it either way. You might have a preference for one or the other, but for this example, I just did one of each. You don't have to do it exactly the way that I did. So yeah, if you want a copy of all this code, I'll post this in the comments down below. And, well, that's the basics of multithreading in Java. Hey you. Yeah, I'm talking to you. If you learned something new, then you can help me help you in 3 easy steps by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro.